Lou Gardens is a mesmerizing subterranean garden that's a hidden gem waiting to be discovered. Imagine stepping into a secret world tucked beneath the surface, where lush greenery, vibrant flora, and a serene atmosphere create an oasis of tranquility. As you enter, you're immediately enveloped by a sense of wonder. The entrance, often inconspicuous, might lead you down a staircase or through a hidden door, heightening the feeling of stepping into another realm. Once inside, you're greeted by a breathtaking sight, a carefully curated blend of plant life, perhaps featuring a variety of ferns, mosses, and other shade-loving vegetation. The space might be ingeniously designed, with natural light filtering through skylights or strategically placed artificial lighting that mimics sunlight, fostering an environment where these plants thrive. The air is often cooler and damp, reminiscent of a rainforest or a secluded grotto. The design might incorporate elements like trickling water features, small streams, or reflective ponds, adding to the ambience of calmness and serenity. One of the most captivating aspects of Lou Gardens is its sense of seclusion. Despite being hidden away, it might be a sanctuary for visitors seeking solace from the bustling world outside. The subdued sounds of rustling leaves or the gentle flow of water create a soothing symphony that contributes to the overall sense of peace. The architecture itself could be stunning, blending seamlessly with the natural landscape. Stone pathways might wind through the greenery, leading you on a journey of discovery, unveiling various hidden corners and niches designed for contemplation or relaxation. Lou Gardens isn't just a place to visit, it's an experience that awakens the senses and fosters a deep connection with nature. Its charm lies not only in its beauty but in its ability to transport you to a different realm, where time seems to stand still and the worries of the world fade away. IDS GeoRadar's Hydra-U is an advanced ground-penetrating radar (GPR) solution designed for utility mapping and subsurface infrastructure investigations. It's a cutting-edge system used to detect and visualize underground utilities, such as pipes, cables, and other buried infrastructure. At its core, the Hydra-U system utilizes ground-penetrating radar technology, which emits electromagnetic pulses into the ground and records the reflections. These reflections bounce back differently based on the materials they encounter, allowing the system to create detailed images of the subsurface. One standout feature of the Hydra-U is its ability to provide high-resolution, real-time data. It can generate 3D maps of underground infrastructure with impressive accuracy, depicting the location, depth, and orientation of various utilities. This information is crucial for planning construction projects, avoiding utility damage, and minimizing excavation risks. The system is also versatile and adaptable, capable of operating in different terrains and conditions. Whether it's urban areas with complex utility networks or rural landscapes, the Hydra-U can efficiently map underground assets. Moreover, its user-friendly interface and software enable easy interpretation of the collected data. Operators can analyze the information quickly, identifying potential risks or areas of interest accurately. This capability enhances decision-making processes, ensuring safer and more efficient excavation or construction projects. Additionally, the Hydra-U offers features like continuous data streaming, which enables real-time monitoring during data collection. This functionality allows for immediate adjustments in survey strategies, ensuring comprehensive coverage of the area of interest. Overall, the IDS GeoRadar Hydra-U stands out in the field of subsurface investigations due to its cutting-edge technology, high-resolution mapping capabilities, adaptability to various environments, and user-friendly interface. It plays a crucial role in reducing risks associated with excavation, enhancing construction planning, and ultimately contributing to safer and more efficient project execution. The Incanova Tilt Ranger is an innovative unmanned aerial vehicle, UAV, designed specifically for underground mining environments. It's a drone equipped with advanced technology tailored to operate in challenging conditions, providing crucial support for surveying, mapping, and inspection tasks in mines. The Tilt Ranger is engineered to navigate through the complex and confined spaces of underground mines where traditional drones or machinery can't easily access. Its design allows it to maneuver efficiently in tight spaces, collecting valuable data without risking human safety. This drone boasts a rugged and durable build to withstand the harsh conditions of mining environments. Its robustness allows it to operate reliably even in environments with high levels of dust, moisture, or varying temperatures commonly found in mines. The Tilt Ranger is equipped with specialized sensors and technologies tailored for mining applications. These may include LiDAR, light detection and ranging, high-resolution cameras, and other sensors capable of capturing detailed data of underground spaces. One of its key features is autonomous flight capabilities. The Tilt Ranger can navigate autonomously through GPS-denied or low-visibility environments using advanced obstacle detection and avoidance systems. This autonomy reduces the need for constant manual control, improving operational efficiency. The drone collects vast amounts of data during its flights, capturing 3D mapping information, structural data, and other essential details about the mine's environment. This data is then processed using specialized software to create detailed maps, identify potential hazards, assess structural integrity, and plan mining operations more effectively. By utilizing the Tilt Ranger for tasks like surveying and inspection, mining companies can significantly enhance safety protocols. The drone minimizes the need for manual inspections in hazardous areas, reducing the risk to personnel. Moreover, its ability to access difficult-to-reach areas streamlines operations and improves overall efficiency in mining activities. The Tilt Ranger is designed to integrate seamlessly into mining workflows. Its data can be incorporated into mine planning, aiding in decision-making processes and optimizing resource allocation. Overall, the Incanova Tilt Ranger represents a significant advancement in the field of mining technology. Its ability to navigate, collect data, and operate autonomously in challenging underground environments provides mining companies with valuable insights, ultimately enhancing safety, efficiency, and productivity in mining operations. A Hyperloop vacuum passenger run involves utilizing the Hyperloop transportation system, a high-speed transportation concept that operates within low-pressure tubes to propel passenger pods at incredible speeds. The Hyperloop operates on the principle of magnetic levitation and reduced air pressure within a tube. Pods carrying passengers or cargo travel through these tubes, experiencing minimal air resistance and friction, allowing for high-speed travel. Hyperloop tubes are maintained at very low pressures to reduce air resistance, similar to conditions found at high altitudes. This low-pressure environment minimizes air drag, enabling the pods to reach extremely high speeds with minimal energy consumption. The pods are propelled using magnetic forces. Electromagnetic propulsion systems, often powered by renewable energy sources, accelerate and decelerate the pods along the tube. Magnetic levitation (maglev) technology suspends the pods above the track, eliminating friction and allowing for smoother and faster travel. During a Hyperloop vacuum passenger run, travelers would board specialized pods designed for passenger comfort and safety. These pods might feature seating arrangements similar to those in high-speed trains or airplanes, prioritizing comfort and safety measures for passengers. The pods gradually accelerate within the low-pressure tube, reaching incredibly high speeds, potentially exceeding 600 miles per hour, 966 kilometers per hour, or more. Despite the high speeds, passengers might experience minimal discomfort due to the smoothness of the ride and the controlled acceleration and deceleration. Safety measures, such as emergency braking systems and fail-safes, would be integrated into the Hyperloop infrastructure to ensure passenger security. Additionally, the tubes would be constructed to withstand various environmental factors and potential hazards. Hyperloop vacuum passenger runs promise several advantages, including significantly reduced travel times between distant locations, decreased environmental impact due to energy-efficient operations, and potential alleviation of traffic congestion in heavily populated areas. In essence, a Hyperloop vacuum passenger run embodies the vision of ultra-fast, energy-efficient, and environmentally friendly transportation. While this technology is still in its developmental stages and undergoing testing, its potential to revolutionize long-distance travel and logistics is a compelling prospect for the future of transportation. Pionen White Mountain is an extraordinary data center located in Stockholm, Sweden, and it's unlike any other you might imagine. Pionen is housed in a former Cold War-era civil defense center, deep underground, carved into the White Mountains. The facility's location within a solid rock hill provides exceptional security against natural and man-made threats, making it highly resilient. The data center's design incorporates robust security measures. Access is restricted and controlled, with multiple layers of security protocols, biometric authentication, and round-the-clock surveillance to safeguard sensitive information stored within. What truly captivates is the interior design. The space is like something out of a science fiction movie, futuristic, with a blend of industrial and high-tech elements. The center features winding tunnels, greenhouses with simulated daylight, waterfalls, and even an aquarium. It's an awe-inspiring fusion of nature and technology. Pionen boasts exceptional reliability and redundancy. The underground location shields it from potential disruptions, while backup power generators, multiple internet connections, and cutting-edge infrastructure ensure uninterrupted operations, even in the face of external challenges. The Triton Vault system represents a groundbreaking innovation in stormwater management, designed to address the challenges of urban development and environmental sustainability. The Triton Vault system consists of modular units made from high-density polyethylene, HDPE, or similar durable materials. These units are stacked together to create an underground stormwater management system. Their modular design allows for flexibility in configuration, making them adaptable to various project sizes and site requirements. A primary function of the Triton Vault system is stormwater retention and filtration. It collects and temporarily stores excess stormwater runoff, preventing it from overwhelming drainage systems during heavy rainfall. The system also facilitates filtration, removing pollutants, sediment, and debris from the water before releasing it back into the environment or redirecting it for reuse. These vaults offer a high storage capacity for stormwater, mitigating the risks of flooding and reducing strain on municipal drainage systems. They efficiently manage water flow, controlling the rate of discharge to prevent erosion and protect downstream areas from potential damage caused by rapid runoff. The system promotes environmental sustainability by facilitating groundwater recharge. By allowing stormwater to percolate slowly into the ground, it replenishes underground aquifers and helps maintain natural water cycles. Additionally, the filtration process within the vaults removes pollutants, contributing to improved water quality in local water bodies. One of the advantages of the Triton Vault system is its underground installation, optimizing land use in urban areas where space is limited. Its integration into the landscape minimizes visual impact while efficiently managing stormwater runoff. These systems are designed to meet regulatory compliance standards for stormwater management. They are durable, resistant to corrosion, and have a long lifespan, ensuring reliable performance and compliance with environmental regulations over an extended period. The modular nature of the system makes it easy to install and maintain. It allows for simple inspection, cleaning, and potential expansion or reconfiguration as needed, providing adaptability to changing environmental or project requirements. In summary, the Triton Vault system offers an innovative and sustainable solution for stormwater management, addressing urban development challenges while promoting environmental conservation, regulatory compliance, and efficient water resource utilization. The Maroochydore Waste Collection System, situated on the Sunshine Coast in Queensland, Australia, represents a cutting-edge approach to waste management. It's a futuristic initiative that utilizes pneumatic waste collection technology to revolutionize how waste is managed in urban areas. At its core, this system employs a network of underground vacuum tubes to transport waste from various collection points to a central processing facility. Instead of traditional garbage trucks, pneumatic tubes use air pressure to transport waste swiftly through a network of pipes. The system offers unparalleled efficiency in waste collection. Residents dispose of their waste into specialized bins stationed at strategic locations. Once deposited, the waste is automatically sucked into the underground tubes, eliminating the need for manual collection and reducing the presence of waste trucks on the streets. By reducing the number of waste collection vehicles on the road, the system decreases carbon emissions and traffic congestion. Additionally, pneumatic waste collection minimizes odors and spillage, contributing to a cleaner and more pleasant urban environment. The underground transport of waste in sealed tubes enhances hygiene standards. It prevents the accumulation of waste in open containers or bins, reducing the risk of pest infestation, bacterial growth, and unpleasant odors associated with conventional waste collection methods. The Maroochydore waste collection system incorporates smart technology to monitor waste levels, optimize collection routes, and ensure timely maintenance of the pneumatic tubes. This integration of technology streamlines operations and enhances the system's efficiency. The system's design allows for scalability, accommodating population growth and changes in waste generation patterns. It can be expanded by adding more collection points and tubes, making it adaptable to the evolving needs of urban areas. Initiatives to educate and engage the community in proper waste disposal practices complement the system. Encouraging residents to sort waste at the source for recycling and composting purposes contributes to long-term sustainability goals. The Maroochydore waste collection system serves as an innovative model for urban waste management, demonstrating the potential for technology-driven solutions to create cleaner, more efficient, and environmentally conscious cities. The Warmly Yours Snow Melt System is an advanced technology designed to efficiently and effectively remove snow and ice from outdoor surfaces, such as driveways, walkways, and patios. The system consists of heating elements installed beneath the surface of the designated area. These elements, often in the form of electric cables or hydronic tubing, generate heat to prevent snow accumulation or to melt existing snow and ice. The system integrates sensors that detect outdoor temperature and moisture levels. When the sensors detect precipitation or freezing temperatures, they trigger the system to activate, ensuring that snow and ice do not accumulate on the surface. The heating elements distribute consistent warmth across the surface, melting snowflakes upon contact and preventing ice from forming. This process results in an efficiently cleared surface without the need for manual shoveling or chemical de-icers. The system is automated, meaning it operates without manual intervention. Once activated by the sensors, it continuously monitors weather conditions and adjusts the heat output as needed, keeping the surface clear and safe. Warmly Yours systems are designed for energy efficiency, utilizing advanced controls and algorithms to optimize heating while minimizing power consumption. They are programmed to activate only when necessary, reducing energy costs associated with continuous operation. The system can be customized to fit various sizes and layouts of outdoor spaces. Growing Underground is a unique urban farming initiative located in London, UK, that harnesses innovative technology to grow fresh produce in an unconventional environment. Underground tunnel situated in disused World War II tunnels 33 meters below the streets of London, Growing Underground utilizes this unconventional space for farming. The tunnels provide a controlled environment shielded from external factors, offering consistent conditions for plant growth. Employing hydroponic and vertical farming methods, Growing Underground optimizes space by growing crops vertically on stacked shelves. This technique maximizes the use of the underground area, allowing for a higher yield of fresh produce within a relatively small space. The underground environment offers a consistent temperature and humidity level year-round. LED lighting systems provide the necessary spectrum of light for plant growth, and the closed-loop hydroponic system uses minimal water resources compared to traditional soil-based agriculture. Growing Underground cultivates a variety of microgreens, herbs, and salad leaves. These crops are harvested at an early stage of growth, packed with nutrients, and often used by restaurants and retailers for their freshness and high quality. By producing food locally, Growing Underground reduces transportation distances, minimizing the carbon footprint associated with food distribution. The proximity to urban markets ensures a fresher product for consumers while supporting sustainable food production practices. The farm employs advanced technologies to monitor and control various parameters such as temperature, humidity, and nutrient levels. This allows for precise cultivation and optimal conditions for plant growth, maximizing yields and quality. Underground farming minimizes the use of arable land, conserving valuable surface space and protecting it from urban development. Additionally, the controlled environment reduces the need for pesticides and herbicides, promoting eco-friendly agriculture. Overall, Growing Underground represents an innovative approach to urban agriculture, utilizing unused spaces to grow fresh and sustainable produce. It's a model that addresses the challenges of food production in urban settings while emphasizing environmental sustainability and efficient resource utilization. Dame Weena Cooper Tunnel Boring Machine, TBM, is a significant infrastructure project in New Zealand, named in honor of Dame Weena Cooper, a revered Maori leader and activist. This TBM was utilized in the construction of the Waterview Connection project, a crucial part of Auckland's motorway network. The Waterview Connection is a major transportation infrastructure project in Auckland, New Zealand. It involves the construction of a motorway link to connect the northwestern and southwestern motorways, aiming to ease traffic congestion and improve travel efficiency in the city. The decision to name the tunnel boring machine after Dame Weena Cooper was a tribute to her immense contributions to New Zealand society, particularly her advocacy for Maori rights and social justice. It was a symbolic gesture to commemorate her legacy. The TBM was a critical component in the construction of the tunnels for the Waterview Connection. It was responsible for excavating and creating the underground passages required for the motorway connection. TBMs are massive machines used to bore tunnels through various types of soil and rock. They use a rotating cutting head to bore through the ground while simultaneously installing tunnel linings to support the excavated area. The Dame Weena Cooper TBM worked tirelessly, excavating soil and rock, advancing through the designated path, and constructing the twin tunnels required for the Waterview Connection. Naming the TBM after Dame Weena Cooper symbolized the fusion of technological progress with cultural recognition and honor. It emphasized the importance of acknowledging the contributions of Indigenous leaders like Dame Weena Cooper in the nation's development. The decision to name such a vital piece of infrastructure after a Maori leader reflects New Zealand's commitment to recognizing and respecting its Indigenous heritage. It emphasizes the role and significance of Maori culture in the country's identity and progress. The naming of the TBM serves as a lasting tribute to Dame Weena Cooper's legacy. It highlights her leadership, dedication, and advocacy for social justice, leaving a symbolic mark on an important infrastructure project in the nation's history. It also serves as a constant reminder of Dame Weena Cooper's impact and continues to inspire conversations about the recognition of Indigenous leaders and the importance of cultural heritage in modern society. The Dame Weena Cooper TBM stands as a symbolic representation of honoring Indigenous leadership and cultural significance in New Zealand's infrastructure development, emphasizing the fusion of technological advancement with cultural recognition and respect. The Taylor Base Isolation System is an innovative seismic protection technology used in building construction to mitigate the impact of earthquakes. Named after its inventor, New Zealand engineer Bill Taylor, this system has been instrumental in enhancing the earthquake resilience of structures. The primary objective of base isolation is to decouple a building from ground motion during an earthquake. It aims to minimize the transfer of seismic forces to the structure, thereby reducing potential damage. Base isolation systems typically involve installing isolators, bearing pads or devices, between the building's foundation and the superstructure. These isolators absorb and dissipate seismic energy, allowing the building to move independently from the ground motion. The Taylor base isolation system employs specialized rubber and steel bearings as isolators. These bearings act as shock absorbers, allowing controlled movement of the building during an earthquake while minimizing the transmission of forces. The system provides protection against seismic forces in multiple directions, ensuring that the building remains stable and resilient against ground motion from various angles. The Taylor base isolation system significantly improves a building's seismic performance by reducing structural damage and enhancing occupant safety during earthquakes. By isolating the structure from the seismic forces, it helps preserve the integrity of the building, reducing the need for extensive repairs or reconstruction post-earthquake. Buildings equipped with base isolation systems often remain functional after an earthquake, allowing for a quicker recovery and continued use compared to non-isolated structures. The Taylor base isolation system is applied during the design and construction phase of buildings, especially in seismic-prone regions. It's integrated into the building's foundation to ensure effective seismic protection. In some cases, the system can be retrofitted into existing structures to improve their seismic resilience. Retrofitting involves adding the isolation bearings between the foundation and the structure. The Taylor base isolation system has contributed significantly to advancing seismic resilience in buildings, particularly in earthquake-prone regions like New Zealand and other seismically active areas worldwide. Implementing base isolation technology enhances the safety of occupants and reduces the vulnerability of buildings and critical infrastructure during seismic events, fostering a more resilient built environment. The Taylor base isolation system stands as a testament to innovation in seismic engineering, offering effective protection against earthquakes and significantly reducing the potential for damage to buildings and structures in seismic zones. The Driveway to Basement Car Lift by Total Lifting Solutions, TLS, is an innovative system designed to efficiently transport vehicles between a driveway and a basement or underground parking area. This system utilizes hydraulic or mechanical technology to elevate and lower vehicles safely and seamlessly. Installed within a property, the car lift system allows vehicles to be driven onto a platform at ground level, which then descends or ascends to the basement or underground parking space. It's a space-saving solution that maximizes parking capacity, especially in properties with limited space or where conventional ramps are impractical. TLS ensures that these car lift systems are designed with utmost safety features, such as robust platforms, secure locking mechanisms, and emergency stop functions. They also provide maintenance and inspection services to ensure the system operates reliably and meets safety standards. This innovative solution from TLS offers convenience, security, and efficient use of space, providing a practical and modern approach to parking management in residential or commercial settings. A dry well drainage system is an underground structure designed to manage excess water runoff by allowing it to be absorbed gradually into the ground. It's particularly useful in areas where there's inadequate natural drainage or during heavy rainfall when stormwater needs effective management to prevent flooding or waterlogging. Typically a hole or excavation in the ground, often lined with materials like concrete, plastic, or permeable geotextile fabric to prevent soil erosion. Inside the dry well, there may be perforated pipes or gravel beds to facilitate water infiltration into the surrounding soil. During rainfall or when excess water accumulates, the dry well collects this water either directly from surface runoff or from connected downspouts, gutters, or drainage systems. The collected water is then stored temporarily within the dry well. The stored water gradually percolates into the surrounding soil, allowing for natural absorption and filtration. By providing a controlled area for water storage and gradual release into the ground, the dry well helps prevent surface flooding and water buildup on properties. Dry well systems effectively manage stormwater runoff, preventing it from overwhelming surface drainage systems or causing erosion. They facilitate groundwater recharge by allowing the filtered water to replenish underground aquifers, contributing to sustainable water cycles. By directing excess water away from the surface, dry wells help reduce soil erosion and prevent property damage. Proper sizing of the dry well is crucial to ensure it can handle the anticipated volume of water without overflow. Periodic maintenance, such as debris removal and inspection, is essential to ensure the system's effectiveness. Dry wells are commonly used in residential properties to manage rainwater from roofs, driveways, and yards. They're also utilized in larger-scale applications such as parking lots, highways, and public spaces to control stormwater runoff. Dry well drainage systems offer an effective and eco-friendly solution for managing excess water runoff, preventing flooding, and contributing to sustainable water management practices. However, proper design, installation, and maintenance are essential for their optimal functionality.